All right, let's see if I can sneak one more video in here this morning on formula writing. And the way I taught you how to do formula writing was using something called the Crisscross Method. You look up the oxidation numbers. And when you do that, you should have a positive and a negative. And make sure that your positive one is the first one. You always want to make sure when you write a chemical formula, you put the positive one first. So look up the oxidation numbers. Drop the signs and swap the numbers. So the metal's oxidation number becomes a subscript on the nonmetal. The nonmetal's oxidation number becomes a subscript on the metal. So we crisscross them. That's where the name comes from. And then finally reduce if you can. Now, general rules that go along with this: when you write a chemical formula, the positive one has to go first, and that's typically a metal. So make sure your metal is always written first, and don't write down the number 1. We don't put the 1s in our chemical formulas because they look like L's. It's always assumed that if there's nothing there, then it's 1. So let's say we want to crisscross calcium and chlorine. We want to figure out what their formula is. We'd find calcium on our periodic table, and it's in group 2. The oxidation number for group 2 is +2. Chlorine is in group 17. The oxidation number for group 17 is -1. So we've got a positive and negative, and that's what we need. Our positive one is first. That's what we need. We can go ahead and drop these signs and swap these numbers. So the 2 comes over here, the 1 goes over there. Now we write the formula, and the positive one goes first, and we don't write down the number 1, and then our negative, Cl2. CaCl2 would be the formula. Reducing typically happens when the oxidation numbers are opposite of each other, like a +1 and a -1, a +2 and a -2, a +3 and a -3. So for example, had I done calcium and oxygen, and I look up the oxidation numbers for those, calcium is a +2, oxygen is a -2. Got a positive, negative, and positive ones first. I crisscross the numbers, but these can be reduced. I can divide them both by 2. Hold on.
Attention staff, if you signed up for a flu shot, she is available in the nurse's office at this time. If you signed up for a flu shot, she is available in the nurse's office at this time.
Go get your flu shots. So if I divide this by 2, that reduces to a 1. If I divide that by 2, that reduces to a 1. So when I write my formula, I don't write Ca2O2, I just write CaO with 1s on each because they've reduced. Now, if it's a transition metal, if it's one of those non-predictable metals, then you would need to know the oxidation number. That's where the Roman numerals come in, but it's really no different than this. A lot of times we write the formulas from the name, and that's where the Roman numeral will be. So if I want to do manganese to bromide, that Roman numeral 2 is in there to tell me the oxidation number for the manganese. Manganese is Mn. It's in the middle of the periodic table, so you can't just look up its oxidation number on the table by group number. So that Roman numeral is there to tell me that manganese is a +2. Bromine is Br. It's in group 17. It's a -1. And again, from that point, we just crisscross like we usually do. Those can't be reduced. We don't write down the 1. You write Br2. We do have to be careful on these negative parts, these second parts. IDE typically means the second part is an element, something straight off the periodic table. ATE and ITE mean polyatomic ion. See both my example here ended in IDE. That's how I knew it was just bromine, just an element, and it wasn't one of those polyatomic ions that we have. If I instead had something like this, potassium sulfate, that ATE on the ending tells me my second half is a polyatomic ion. Potassium's just K, that's an element. The ATE means it's not just sulfur over here, it's sulfate, which we have to know is SO4, and it has a -2 charge. Potassium, we look up on the periodic table, it's a +1, group 1. 1 goes over here, 2 goes over there. So it's K2. When it comes to these polyatomic ions, we usually have to put them in parentheses before we write the subscripts on them, but since this is a 1, and we're not going to write it down, we don't have to use those parentheses this time. Let's do one where we need parentheses. Let's do aluminum nitrate. And again, the ITE ending tells me that the second half of this is a polyatomic ion. Aluminum is just Al, straight off the periodic table. Nitrite is NO2. It has a -1 charge. It's one of the ones that you have to know. Aluminum's in group 13. Group 13 is a +3. So we're bringing a 3 over here. We're bringing a 1 over there. For the aluminum, nothing special. It's a 1. We don't write down 1s. But before we can put the 3 on the nitrate, I've got to put it in parentheses and put the 3 on the outside. We have to protect the nitrite. We have to make sure that its chemical formula always stays the same, that it never changes. And that's what those parentheses do. It builds a wall around it and protects it so it stays NO2. It literally means 3 nitrates. There's oxidation numbers in case you don't know. Group 1 is a +1. Group 2, +2. Group 13, +3. Then we skip group 14. Then we go to 15. That's your -3. Group 16 is -2. And group 17 is -1. These apply only to the nonmetals in those groups. Nonmetals are the ones that are to the right of the metalloids. It's 1, 2, 3, 3, 2, 1 when you're thinking about it.